First, we remove the sidebar to give more space for the graphics window. The AGDB format is the ANSYS geometry database. It contains our geometry, and we've named selections which will give the relevant labels to the different surfaces. CAD systems have similar options. For example, publications can be used to give labels in CATIA version 5. The tessellation method we choose here is called tessellation refinement, and this will give us a disconnected STL-like faceting. We also set a tolerance of 0.1 millimeters, which will enable us to get better feature capture on curved areas of the geometry. Fluent meshing uses ANSYS Workbench CAD reader technology. Neutral formats such as STEP and IGES are included, but many formats require an additional license option. Here we can use clipping planes to allow a better viewing of the geometry inside. We can also display objects from the list on the left-hand side and alter the graphics from the drop-downs at the top to show free faces, and then we can also choose to select whether to show edge zones or face zones. Here we use a hotkey, Ctrl-B, to switch to the Object Select mode. The right mouse button is then used to select the object, and we can use Ctrl-Shift-N, another hotkey, to rename the objects very quickly, and we see this change in the list on the left-hand side. Similar can be done with boundary zones by using the Ctrl-Z hotkey and following up with Ctrl-Shift-N to rename boundary zones. Now we add a material point which can be used for telling the wrapper where to extract the fluid domain. And it also labels our final fluid or solid zones with the same name as that material point. Next, we add some size functions. These size functions will give us our different sizes on different parts of the geometry. We add functions to resolve the curvature on the car, for example, and a higher resolution for curvature on a wing. Proximity can be added between edge zones to capture regions where we need to get a certain number of cells across, and refinement regions for wakes and so on can be used via the body of influence option. We start by adding a curvature size function for all the car boundary zones, and a more refined one with a lower curvature angle and a lower max size as well for the wing alone. Here we add a proximity size function based on the car edge zones to ensure we get 3 cells across small features automatically, such as wing trailing edges. The F4 hotkey is used to switch to polygon mode, and we can select edges graphically. Then we can switch back using F4 to selection mode, and we can remove some of the wind tunnel feature edges. We can give a smaller min size, 0.5mm here, purely for the proximity function. Curvature will only refine to 1mm, however. Now we add body of influence size functions, which will capture wakes behind some of our objects. We have 3 refinement boxes, so we add 3 body of influence size functions, and we specify the max cell size within that body of influence and a growth rate away from that cell size. After computing the size field based on the size functions defined, we can use the Ctrl Y hotkey and right mouse button anywhere in our geometry to probe the sizes before using them. We can also write out this size field and re-import the CAD with these settings using conformal CFD type faceting. Other options for usage of this size field include wrapping, remeshing, cut cell, and we can also apply filters to limit or scale the current size field information. Here we will wrap the object using the new High Geometry Recovery option, which will remesh the wrapped surfaces on the fly. We provide a new name for the wrap object and the material point to tell the wrapper where to wrap from. We could also use a resolution factor below 1 to apply a scale factor to the size field during the wrapping process for better feature capture. For the subsequent remesh, the unscaled sizes would be used to give exactly what the user requested. To understand the validity of our final mesh, we can use the diagnostics tools. Here we can find and fix skewness issues. Here's a typical crossover area in a wrapped mesh where we haven't quite resolved a very thin area. This can be a problem if we want to resolve the flow in this region, but sometimes it's also very beneficial. We would struggle to grow good quality volume elements if we do resolve this feature. As this area of the geometry is a region of little interest, we can relax our improve criteria. That is, we don't really care if we move the geometry here during our improvement, or if the boundary between the adjacent zones is altered a little bit. It's not going to affect the final solution much. Other hotkeys used here include Ctrl-Z to select boundary zones and using Ctrl-Shift-H to then hide those boundary zones that we've selected. Ctrl-Shift-C enables a colour selection mode, and for example we can colour by normal here to see which way the prisms will grow. Grey shows the direction of growth and yellow shows the opposite direction.